qui a son magistère en physique théorique. Il a obtenu à l'université de
Hello, can you hear me?
مرحبا, Dr. Alalan. Il est en direct avec nous.
Hello?
Oui, Monsieur Alalan. Soyez le bienvenu.
Could someone say everything is fine?
Hello.
Can you see my slides?
Hello, Dr. Alalan. Okay.
Hello, can you hear me? Just write in the chat window that you can see my slides and they can hear me. Vous m'entendez?
Oui, on vous entend, Dr. Alalan. Soyez le bienvenu.
Hello? Allô? D'accord, je commence? Ok, très bien. Okay, good morning. Thank you for inviting me. It's a pleasure to be here with you. Yes. With my presentation, I would like to give you some overview about the high performance computing and big data and AI. My name is Lalan. After finishing my magister thesis in Physics University of Moscow in Sweden, I moved to Germany to do my PhD in theoretical quantum physics, which I finished in 2007. And since this time, I'm working as a researcher scientist at the Leibniz Rechenzentrum in Garching in Munich. Garching is in the south of Germany. It's in the near from Munich here, which is far away this distance to Alger. And our research center here, there is different research fields, and this is our building here. We have our offices here, and some research centers, visualization centers, and all our hardware for big data, for AI, for high performance computing are in those two cubes here. My tasks there is I'm more as a software specialist and I'm helping our users to use and to optimize their framework, their codes, to run much more efficiency in our hardware. Because as you know, the hardware is there is each 1 or 2 years they are updating hardware. There is new processors are coming, new technologies coming, and sometimes like the programming languages, the codes and so you need to do the modernization of those codes to fit those hardware. And my research interests are many heterogeneous programming languages. What I mean with heterogeneous is you have CPUs, which you know already, but there is a new technology. We connect those CPUs to some GPUs, which is GPU is for graphics unit processors, and those GPUs are what we mean heterogeneous. You need to program such hardware between CPU and GPU, and this such hardware, this is very useful for AI and big data framework. I am also certified from DLI and NVIDIA. Certified instructor for teaching CUDA, CUDA for multi-GPU, single GPU, and multi-GPU across multi-node. I collected here in this presentation some information. Maybe, I hope they will be useful for you, where I can, I will give like an overview about the high performance computing and the performance, the actual performance of today, and which I find very important to solve and treat problems with big data and deep learning and machine learning frameworks. Here at LSE, we are we belong to the Bavarian Academy of Science and Humanity, We are like 250 scientists and IT employees. We are celebrating this year like 16 years of IT. We are like a research center for all the University of Munich and of Bavarian research centers. And together with in Jülich and HLRS in Stuttgart, we are represented German like in worldwide and European-wide under the National Supercomputing Center. And then under European-wide, as you can see here, example in this PRAISE project, the European Supercomputing Center, where those hosting members, Germany and France and Italy, Switzerland and Spain, and there is more than 26 countries involved there. And this, the ideal, because you have Europe, United States, and ASEAN, there is like competition. Who will have the fastest hardware and the new technology, because having the fastest hardware, you can solve many problems. What we are providing here, like we are responsible for all the emails, we are responsible for the fastest network between the hospitals, between the universities, between all the research centers. We have then a large, very large storage where we store all the data. Example here, there is the data from the hospitals are stored by us, like the doctors can check the data of the patients directly in our storage. And then we provide like some cloud computing. My area, my research area is in this here below. We are responsible for high performance computing. We have a machine Vidéo1. We have like also machines for under Bavarian state. I am also like involved in many teaching and consultancy of our users. Here it's not very important for you. This is access of our hardware. I just would like here to show you that we also mirror all our huge data. We do like we mirror them, we save them in one place just for reason. And then we have some very useful hardware for AI and for solving big data problems in AI, which is based on the GPU. If you remember the word heterogeneous, like they are connected to some GPUs which are powerful hardware for solving problems in big data and AI. And our fastest machine, it's what I'm having in my background. It's a CPU-only machine. It's not, and I think it's the largest machine CPU in the world. And but next we are becoming like 2025 machine, but it will be accelerated. They will have like some GPUs, and it is performing like it can reach like 20 petaflops, like 10 puissance 15 opérations par seconde. And she has like more than 300,000 like cores. They are Skylake cores, and we can solve like problems up to more than 700 terabytes, plus de 700 terabytes. Et le disque dur est plus de 70 terabytes, 10 puissance 18. Now let's come back to your topic here. Which I like here, it's about artificial intelligence and machine learning. I started with this hardware because the hardware is very useful for artificial intelligence and big data and digital stuff. Before I'm going to define what artificial intelligence, let's first define what intelligence is. If we define intelligence like the ability to achieve a complex goal, like d'atteindre un problème compliqué, where complex is structured, si on prend a hammer, like a marteau, can help us to achieve a complex goal. Un marteau peut nous aider à atteindre un problème, à solver un problème compliqué, which is not biological, which is artificial. That means things are happening in state of the art, what we consider artificial intelligence. Like building tools are not biological and are artificial to help us, for solving problems, which we mean artificial intelligence. Like building, let's talk first about the power of computers. Like between the 50s and the 80s, computers mostly looks like unstructured-based programming, like serial based on problem serial programming, and computer will help us to work in some complexity, like if statement or tools like some loops, codes and so on. And those which mean that if you define some strategy in these computers and design like this strategy which you can understand as a human being, like you can understand what, and the computer can help you in these strategies. Now, if we define intelligence as the ability to achieve a complex goal, learning, when you learn, then you can retrouver avec apprendre, atteindre un problème plus compliqué. You can achieve more complex goals today as yesterday. That means learning is changing the intelligence, is changing thinking. So from machine learning, we get the ability to just follow instruction and tools which can be better for solving problems. And deep learning are the subset of machine learning, where the difference is in that we have algorithms that inspire from the human brain, which allows you to learn strategies that inspire from the human learning, all those strategies. Let's go a little bit more in details here. Here, the lifetime gained intelligence in a lot of ways in the past. Like again, we define intelligence as the ability to achieve a complex goal. So over generation, my kid here, mon enfant, get bigger. So I am learning over generation, achieve more complex goals today as yesterday, what I can achieve yesterday. So with the brain, we can learn with one generation, une vie, one